There exists a profound paradox in the human condition. We are creatures of Earth, yet we dream of stars. Our bodies evolved under gravity's patient hand, shaped by atmospheric pressure, bathed in solar radiation filtered through protective layers of gas and magnetic fields. Every cell in your body carries the signature of this world, the specific pull of 9.8 meters per second squared, the rhythm of a 24-hour day, the chemical composition of air that happens to be 78% nitrogen and 21% oxygen. You are, in the most literal sense, made of Earth. And yet, standing on this blue marble, we look up at the infinite darkness and feel an irresistible pull toward it. This tension between what we are and what we aspire to become forms the foundation of one of humanity's most audacious dreams, becoming a spacefaring civilization. But here's what we rarely consider in our enthusiasm for colonizing Mars or reaching distant star system space. It doesn't just challenge our technology, it challenges the very essence of what it means to be human. Because when we talk about spending millennia among the stars, we're not just talking about survival. We're talking about transformation. We're talking about evolution in real time. We're talking about the day when someone born in the cold void between stars might look at pictures of Earth and feel nothing. No connection, no longing, no sense of home. 10,000 years. It's a number large enough to boggle the mind, yet small enough to contemplate. 10,000 years ago, humans were just beginning to plant their first crops, domesticate their first animals, build their first permanent settlements. We hadn't invented the wheel yet. We hadn't discovered writing. The pyramids of Egypt wouldn't rise for another 6,000 years. Rome wouldn't fall for another 10,500 years. And yet, here we are, the descendants of those early farmers, with computers in our pockets, vaccines in our veins, and rovers on Mars. Now imagine the reverse journey. Not 10,000 years of progress on Earth, but 10,000 years adrift in space. 10,000 years of living in artificial habitats, breathing recycled air, eating synthesized food. 10,000 years of children who never feel rain, never swim in an ocean, never climb a tree. What becomes of humanity then? What do we lose? What might we gain? And most unsettling of all, would we even recognize ourselves? The human body is a masterpiece of adaptation, but it's also remarkably fragile when removed from its native environment. Take gravity, for instance. That constant downward pull you barely notice. As you read these words, it's not just keeping you grounded. It's maintaining your bone density, regulating your cardiovascular system, informing your spatial orientation, even affecting how your cells divide and differentiate. Astronauts who spend just 6 months on the International Space Station experience measurable bone loss, muscle atrophy, vision changes, and shifts in their immune function. Their bodies begin to transform, to adapt to an environment without up or down, without the constant pull that shaped their ancestors for hundreds of millions of years. Now, multiply that 6 months by 20,000. 10,000 years of human generations born and raised in microgravity or low-gravity environments. Natural selection doesn't stop just because we've left Earth. In fact, it accelerates under extreme environmental pressure. Those individuals whose bodies happen to cope better with low gravity would have subtle advantages. They'd experience fewer health complications, maintain better muscle function with less effort, perhaps even find mobility easier in three-dimensional space over hundreds of generations. These small advantages compound. Bones would become lighter, less dense, because why maintain the structural integrity needed to support yourself against Earth's gravity when there's no gravity to fight? Muscles would reconfigure, perhaps becoming more efficient in different ways, optimized for movement in 3 dimensions, rather than bipedal locomotion across a flat surface. But the changes wouldn't stop at the musculoskeletal level. The cardiovascular system, designed to pump blood upward against gravity, would find itself suddenly working in an environment where up has no meaning. Hearts might become smaller, more efficient at different pressures. Blood vessels might lose the complex valve systems designed to prevent backflow. The inner ear, that marvelous organ that helps you maintain balance on Earth, might atrophy over generations, replaced by enhanced proprioception or entirely new sensory mechanisms for spatial orientation. And then there's radiation. Earth's magnetic field is an invisible shield, deflecting the worst of the sun's rage and the cosmic rays that sleet through the galaxy. We live our entire lives under this protection, never realizing how dependent we are on it until we leave. In space, that protection vanishes. The radiation levels in deep space are hundreds of times higher than on Earth's surface. Your DNA takes constant hits from high-energy particles. Most of these hits are repaired by your cellular machinery, but some slip through, causing mutations, increasing cancer risk, potentially affecting germ cells and thus future generations. 10,000 years of this exposure would create enormous selective pressure. Those whose DNA repair mechanisms happen to be slightly more efficient, whose cells happen to be slightly more resistant to radiation damage, they survive longer, reproduce more successfully. Over time, the human genome begins to shift. Perhaps we develop more robust DNA repair proteins or cellular mechanisms that can better handle oxidative stress. Perhaps our cells learn to enter protective dormancy more readily, or develop novel ways to shield genetic material. Evolution doesn't plan ahead, but it's remarkably good at finding solutions to persistent problems. Consider also the profound isolation of space travel. Not just psychological isolation, though that's significant, but genetic isolation. When a population becomes separated from the main breeding group, it begins to diverge. This is called genetic drift, and it's one of the primary mechanisms of speciation. A small group of humans leaving Earth to colonize a distant world wouldn't carry the full genetic diversity of humanity with them. They'd represent a subset, a sample, and as they reproduce in isolation, generation after generation, their gene pool would drift further from Earth's, shaped by different selective pressures, different random mutations, different founder effects. Imagine 3 separate colonies, one on Mars, one in orbit around Jupiter, one on a generation ship heading to Alpha Centauri. Each starts with perhaps a few thousand individuals, carefully selected for genetic diversity, but still representing only a fraction of human variation. Mars colonists face low gravity and high radiation. Jupiter orbit inhabitants live under even lower gravity, but with intense radiation from Jupiter's magnetosphere. The generation ship crew experiences artificial gravity from rotation, but complete isolation from any planetary environment, total dependence on closed-loop life support. After 10,000 years, these 3 populations might be as genetically distinct from each other as modern humans are from Neanderthals, different enough that reproduction between them becomes difficult or impossible, different enough that they develop distinct physical features, different disease susceptibilities, different optimal diets, different tolerances for environmental conditions. We wouldn't have one humanity anymore. We'd have multiple human species, each adapted to their particular corner of the cosmos. But physical changes are only part of the story. Perhaps the more profound transformations would occur in the realm of psychology and culture. Human psychology evolved in small tribal groups on the African savanna. Our emotions, our social instincts, our fears and desires, they all bear the fingerprints of that ancestral environment. We fear snakes and spiders more readily than we fear cars or electrical outlets, despite the latter being far more dangerous in modern life. We crave sugar and fat because they were rare and precious in our evolutionary past. We form tight social bonds because cooperation was essential for survival. We tell stories because storytelling strengthens social cohesion and passed down survival knowledge. What happens to these deep psychological structures when the environment changes so radically? Children born on a generation ship wouldn't fear falling from trees because there are no trees to fall from. They wouldn't develop an instinctive wariness of predators because there are no predators. They wouldn't feel the same connection to natural cycles of day and night, seasons, weather, because these things would be artificial, controlled, predictable. Their entire relationship with nature would be fundamentally different from ours. And perhaps more importantly, their relationship with technology would be different. For us, technology is something external, something we use and interact with, but remain fundamentally separate from. But for children raised in space habitats, technology isn't separate. It's the entire environment. The air they breathe is produced by machines. The water they drink is recycled through technological systems. The light that illuminates their world comes from artificial sources. The gravity they feel, if any, is created by rotation or acceleration. Every aspect of their existence depends on technology functioning perfectly, constantly, reliably. This creates a relationship with technology more intimate than anything we've experienced on Earth. It's not like depending on a smartphone or a car. It's like depending on your lungs or your heart. And over generations, this relationship would shape psychology in profound ways. Perhaps spaceborne humans would develop an intuitive understanding of complex systems that seems almost supernatural to Earthborn minds. Perhaps they'd think in terms of systems and feedback loops more naturally than we do. Perhaps their sense of security would be tied not to territory or resources in the traditional sense, but to the health and resilience of technological systems. Or consider how concepts of home and belonging might shift. For us, home is a place, a specific location on Earth, with particular geographic features, climate, ecosystem. We talk about homeland, motherland, native soil. Our identities are often tied to places. I'm from New York, I'm Californian, I'm from the Midwest. But in space, place becomes more fluid. A generation ship is always moving. An orbital habitat might be relocated. Even a Martian colony exists on a world that's fundamentally hostile to human life without technological intervention. Home becomes not a place, but a community, a set of relationships, a shared purpose. Identity might shift from geographic to genealogical or ideological. Language would change too, inevitably. New environments create new concepts that require new words. Space colonists would develop technical vocabularies for their specific environments, terms for types of radiation, orbital mechanics, life support systems, zero-gravity phenomena. But beyond technical jargon, the very structure of language might shift. Spatial metaphors dominate human language because we evolved in a world with a constant gravitational down. We talk about feeling down or having high spirits, about things being up in the air or falling through. In microgravity, these metaphors lose their immediate physical referent. New metaphors would emerge, grounded in the actual experience of three-dimensional movement, of cycling through the ship, of maintaining position, of drifting. And then there's the question of values and ethics. Human ethical systems, developed in the context of resource scarcity, tribal competition, and natural environments. Many of our deepest moral intuitions relate to fairness in distribution, reciprocity, loyalty to groups, care for kin, respect for authority, and sanctity of natural orders. But in a space habitat, the context changes dramatically. Resources aren't just scarce, they're absolutely limited and must be carefully managed. Individual actions can threaten the entire community in immediate and catastrophic ways. Waste isn't just wasteful, it's potentially lethal. This creates enormous pressure toward collectivism, toward strict social control, toward prioritizing group survival over individual freedom. A person on Earth who wants to go live in the woods alone might be considered eccentric, but they're not threatening everyone else's survival. A person on a space station who decides to hoard oxygen or waste water could kill everyone. The moral weight of individual actions changes when you're living in a closed system where everything is connected to everything else. Over 10,000 years, ethical systems would evolve to match these realities. Perhaps spaceborne humans would develop moral intuitions about system maintenance and resource cycling as strong as our intuitions about kinship and fairness. Perhaps they'd feel visceral disgust at wastefulness, the way we feel disgust at contaminated food. Perhaps their sense of individuality would be more fluid, more integrated with collective identity, because individual survival is so obviously dependent on collective success. Religion and spirituality would transform as well. Many Earth religions emphasize our connection to nature, to the cycles of seasons, to the land. Creation myths speak of gods forming humans from clay, breathing life into dust, creating land and sea. Sacred sites are tied to specific geographic locations, but in space, these connections break down. There is no sacred mountain when you're in the void between stars. There is no river to baptize in, no earth to bury your dead in, no promised land to journey toward. Or rather, the promised land is always ahead, always unreached, perhaps unreachable. New spiritual frameworks would emerge, perhaps centered on the journey itself rather than destination, perhaps emphasizing the interconnectedness of all systems, the precious fragility of life, the responsibility of maintaining the bubble of habitability in an hostile universe, perhaps developing mythologies around the founding journey, the moment of departure from Earth, the ancestors who made the leap into the dark, or perhaps moving away from spirituality entirely, toward a more purely materialist worldview where technology is providence and maintenance is prayer. The very concept of nature would need to be reimagined. For us, nature is the given, the unmanaged, the wild spaces beyond human control. But in a space habitat, there is no nature in this sense. Every plant is deliberately cultivated. Every ecosystem is engineered. The only wilderness is the lethal void outside the hull. Children might grow up, never experiencing anything truly wild, never seeing an animal that wasn't deliberately placed there for a purpose, never encountering a plant that wasn't part of a managed ecosystem. This could create a consciousness radically different from ours, one where the very distinction between natural and artificial breaks down, because everything is artificial, everything is managed, everything exists within a design system. Or it could create a deep longing for wilderness, for the uncontrolled, for the truly alien. Spaceborne humans might become obsessed with Earth, precisely because it represents the one place where nature still exists in its full, chaotic, unmanaged glory. And what of human relationships and reproduction? On Earth, we can afford to be somewhat casual about reproductive success, because the environment is forgiving enough that many variations can survive. But in space, genetic diversity might be carefully managed. Reproductive rights might be regulated to prevent inbreeding or maintain optimal population size. The very private nature of reproduction might give way to more collective decision-making about who reproduces and when. This isn't necessarily dystopian. Many successful societies throughout history have had various forms of marriage regulation, reproductive customs, and collective involvement in family formation. But it would represent a significant shift from modern Western values of reproductive freedom and privacy. And over 10,000 years, if reproductive patterns are shaped by collective needs rather than individual choice, this too would create selective pressure, favoring individuals who are psychologically comfortable with collective reproductive decision-making. Family structures might change as well. The nuclear family, 2 parents and their children, is actually a relatively recent development in human history. For most of our evolutionary past, we lived in extended kinship networks, where child-rearing was more communal. In space habitats, particularly on long-generation ships, we might see a return to more communal child-rearing simply out of practical necessity. Children are too valuable, require too many resources, and represent too much of the colony's future to be left solely to biological parents. Everyone has a stake in raising the next generation successfully. This could create humans whose primary emotional bonds are not to biological parents, but to the community as a whole, whose sense of identity is less about family lineage and more about generation cohort or functional role within the community, who think of themselves less as individuals from specific families and more as cells in a larger organism. Now consider the impact of time dilation if we're talking about relativistic travel. A generation ship traveling at a significant fraction of light speed would experience time differently than Earth. Decades might pass on Earth while only years pass on the ship. The crew wouldn't notice. Time would feel normal to them, but the effects would be profound. Messages from Earth would arrive increasingly delayed and out of sync. By the time a reply comes back to a question asked from the ship, everyone who asked the question might be dead. The cultural references in messages from Earth would become increasingly alien as Earth's culture evolved at a different rate. Eventually, communication might cease altogether. Earth becomes not just physically distant, but temporally disconnected, a place that exists in a different time stream, where history unfolds at a different pace. The ship's inhabitants would truly be alone, carrying forward a version of human culture that's frozen at the moment of departure, evolving in its own direction while Earth moves in another. 10,000 years of this isolation, this independent evolution, would create something genuinely alien. Not alien in the sense of little green men from Mars, but alien in a more unsettling way, beings that share our ancestry, our deep evolutionary past, but have diverged so far that we might struggle to understand each other. They'd look at our concerns and find them quaint or incomprehensible. We'd look at theirs and feel the same. They might have trouble understanding our attachment to nation-states, our concept of privacy, our resistance to genetic engineering, our romantic notions about wilderness and nature. We might have trouble understanding their comfort with collective decision-making, their lack of connection to planetary surfaces, their integrated relationship with technology, their fundamentally different relationship with time and distance. And here's the truly humbling thought. They wouldn't be wrong, and we wouldn't be right. They'd simply be adapted to their environment, as we're adapted to ours. Evolution has no goal, no endpoint, no preferred direction. It only optimizes for survival and reproduction in a given environment. Humans who evolve in space for 10,000 years wouldn't be failed Earth humans. They'd be successful space humans. Different doesn't mean inferior or superior. It just means different. But perhaps the most profound change wouldn't be physical or even psychological in the conventional sense. It might be cognitive. The human brain is extraordinarily plastic, especially during development. The environment we grow up in literally shapes the structure of our neural networks, determines which connections strengthen and which atrophy, influences how we perceive and process information. Children growing up in three-dimensional microgravity environments would develop spatial reasoning skills that might be incomprehensible to Earthbound humans. Moving in 3 dimensions without a consistent down requires fundamentally different neural processing than walking on a flat surface. Their brains would wire themselves differently from birth, creating cognitive capabilities we can barely imagine. Similarly, growing up surrounded by complex technological systems, where understanding system dynamics isn't just useful, but essential for survival, might create intuitive grasp of complexity that seems almost superhuman to us. Not because they're smarter in some general sense, but because their brains developed in an environment that rewarded and reinforced different types of thinking. Or consider the impact of virtual and augmented reality, which would likely be ubiquitous in space habitats simply because physical space is limited, but virtual space is infinite. If children spend significant portions of their developmental years in virtual environments, their sense of reality itself might be different from ours. The distinction between physical and virtual might blur in ways that would be philosophically troubling to us, but perfectly natural to them. Language processing might change too. In environments where everyone is constantly connected through technology, where communication happens through multiple channels simultaneously, text, voice, video, data streams, biometric sharing, the nature of linguistic communication itself transforms. Perhaps spaceborne humans would develop the ability to parse multiple information streams simultaneously in ways we can't, or communicate ideas through rich multimedia combinations that are more efficient than linear speech. Mathematics and abstract reasoning might become more intuitive because the environment itself is more obviously governed by mathematical relationships. When your survival depends on understanding orbital mechanics, radiation shielding calculations, life support system equations, closed-loop ecology models, mathematics isn't an abstract academic subject. It's the language that describes reality at its most fundamental level. 10,000 years of cognitive evolution in these directions would create minds that process information differently, perceive reality differently, perhaps even experience consciousness differently than we do. Not better or worse, but different in ways that might make deep communication between Earth humans and space humans genuinely difficult. And we haven't even touched on deliberate genetic engineering or technological enhancement, which seems almost inevitable over such timescales. Once we have the capability to modify human genetics, and we're rapidly approaching that threshold, the selective pressures become conscious choices. Why let evolution slowly adapt humans to space when we can engineer the adaptations directly? Denser bones that don't atrophy in low gravity, more efficient cardiovascular systems, enhanced radiation resistance, better vitamin D synthesis under artificial light, improved circadian rhythms that can adjust to non-24-hour cycles, the ability to hibernate during long transits, enhanced cognitive abilities for spatial reasoning or system thinking. The possibilities are endless, and the incentives are overwhelming. A space colony that embraces genetic engineering to better adapt their children to the space environment would have enormous advantages over one that doesn't. Their children would be healthier, more capable, better suited to their environment. Over time, this would create population-level differences that go far beyond natural selection. We'd be looking at consciously designed divergence, human-directed speciation. This raises profound questions about identity and continuity. At what point do the changes become so significant that we're no longer talking about humans at all, but about something new? Is it when we can no longer interbreed with Earth humans? When our psychology becomes incomprehensible to each other? When our values and goals diverge completely? Or is there some essential core of humanity that persists regardless of physical or cognitive changes? These aren't just philosophical questions. They have practical implications for how space colonists would relate to Earth, how they'd see themselves, what moral obligations they might feel toward their ancestral home. A colony that still considers itself fundamentally human, just adapted to a new environment, might maintain strong ties to Earth, see themselves as part of a larger human story. A colony that sees itself as something new, as having transcended Earthbound humanity, might feel no particular connection or obligation. And from Earth's perspective, how do we relate to these descendants? Are they still us, just living elsewhere? Are they our children, to be protected and nurtured? Are they something new, to be regarded with curiosity, or perhaps even fear? History shows us that humans haven't always treated other human populations well, even when the differences are minor. How would we treat populations that have diverged so dramatically that they might seem alien? There's a darker possibility here too. What if the adaptations needed for successful space colonization require giving up things we consider essential to humanity? What if being truly adapted to space means losing our connection to nature, our capacity for certain emotions, our ability to appreciate beauty in traditional ways, our sense of individual autonomy? What if the price of becoming a spacefaring species is, in some meaningful sense, ceasing to be human as we understand it? This is the paradox at the heart of long-term space colonization. We venture into space to preserve and extend humanity, to ensure our survival beyond Earth's eventual demise, to fulfill what many see as our destiny among the stars. But in doing so, we might transform ourselves so completely that what survives isn't humanity as we know it, but something else, something descended from us, carrying our genetic heritage, but no longer recognizably us. Is that acceptable? Is that tragic? Or is it simply the nature of change, the inevitable consequence of life spreading to new environments? After all, we're not the same as our ancestors from 10,000 years ago either. Agriculture changed us. Civilization changed us. Technology is changing us. Perhaps the change from Earth human to space human is just the next step in an ongoing process of transformation that's been happening since our ancestors first climbed down from the trees. But there's a difference in scale and kind. The changes wrought by agriculture and civilization were significant, but they happened gradually, over hundreds of generations, in an environment that remained fundamentally similar. The changes wrought by space colonization would happen in an environment so radically different that the selective pressures would be unprecedented in their intensity. And unlike agricultural humans looking back at hunter-gatherers, space humans looking back at Earth, humans would be looking back at an environment they could never survive in without technology, at a life they could never live. A person born and raised in zero gravity who returns to Earth as an adult might find the experience crushing literally. Their bones, their muscles, their cardiovascular system would be adapted to weightlessness. Earth's gravity would be overwhelming, perhaps even fatal. This creates a one-way door. Once you've adapted to space over multiple generations, returning to Earth might not be an option. The cosmic diaspora becomes permanent, irreversible. We become not one species living in different places, but different species that happen to share a common ancestor. The psychological weight of this permanent separation deserves deeper consideration. Throughout human history, migration has been a constant theme. People leave their homelands for opportunity, safety, or adventure, but the homeland remains a place you could return to, a touchstone for identity, even if you never go back. But space migration of the kind we're discussing would be different. It's not moving to a new country. It's moving to a fundamentally different reality with no possibility of return. The first generations would feel this acutely. They'd be Earthborn, or only one generation removed, carrying memories or stories of blue skies, rain, oceans, forests. They'd know what they'd given up, what they'd left behind. But their children, born in the void, would know Earth only as myth, as distant history. And their children's children might regard Earth the way we regard the African savanna, an interesting fact about our evolutionary past, but not really relevant to daily life. This generational shift in perspective would fundamentally alter the meaning of the journey itself. The first generation embarks on a mission: colonize Mars, reach Alpha Centauri, establish humanity beyond Earth. They have purpose, direction, a clear goal. But what about Generation 50? Generation 200? They're not on a mission. They're just living. They were born into this existence, didn't choose it, and will die without ever reaching whatever destination their ancestors aimed for. This could create profound existential challenges. Human psychology craves meaning, purpose, a sense that our existence serves some larger goal. For most of human history, that meaning came from immediate concerns: survival, family, community, or from religious frameworks that placed individual lives within cosmic narratives. But on a generation ship traveling for thousands of years, what's the meaning? You're born, you maintain the systems, you reproduce, you die, and the ship continues. You're neither at the beginning nor the end of the journey, just a link in an endless chain. Some cultures might solve this through religion, creating mythologies that sanctify the journey itself, that frame each generation's maintenance of the ship as sacred duty. Others might find meaning in incremental progress, in the slow accumulation of knowledge, in the gradual improvement of the habitat. Still, others might struggle with nihilism, with the sense that their individual lives are meaningless cogs in a machine they didn't choose and can't escape. The psychology of confinement would be another significant challenge, especially in the early centuries before populations have had time to adapt. Humans evolved as wide-ranging creatures. Even the most sedentary agricultural societies had access to varied landscapes, to horizons, to the sense of space extending beyond immediate sight. We have psychological needs for variety, for new experiences, for a sense of freedom to move and explore. A space habitat, even a large one, is fundamentally limited. You can walk from one end to the other. You know every corridor, every room, every viewport. There are no distant mountains to wonder about, no far-off lands to dream of visiting, no true wilderness to explore. Everything is known, mapped, controlled. The walls are always there, just beyond sight, containing you. This could manifest in various psychological pathologies: claustrophobia, depression, anxiety, a desperate hunger for novelty that can't be satisfied. Early colonists would need extensive psychological screening and support, but over generations, selection would favor individuals who cope better with confinement, who find satisfaction in familiar spaces, who don't crave the horizon. We might evolve to be psychologically adapted to small, contained environments, losing something that's been central to human psychology for hundreds of thousands of years. The social dynamics in such confined spaces would be intense. On Earth, if you have conflicts with your community, you can leave. You can move to a new city, a new country, start fresh somewhere else. But on a space station or generation ship, you're stuck with the same people. There's nowhere else to go. This creates enormous pressure to maintain social harmony, to resolve conflicts, to find ways to live together peacefully, because the alternative social breakdown is existentially threatening to everyone. Historically, small, isolated communities have dealt with this in various ways. Some develop extremely strict social norms and harsh punishments for deviance to maintain order. Others develop sophisticated conflict resolution mechanisms and place high value on social harmony. Still, others experience periodic outbursts of violence when tensions become unbearable. A space colony would need to figure out which strategies work, and those strategies would shape the culture profoundly. Over 10,000 years, This would select for individuals who are naturally good at conflict de-escalation, who value harmony, who can tolerate close proximity to others without stress. The more individualistic, conflict-prone, socially aggressive members of the population would face significant disadvantages, not necessarily through violent exclusion, but through subtle social mechanisms, being less trusted, having fewer reproductive opportunities, being excluded from important decision-making. The result would be populations that are, on average, more socially harmonious, more conflict-averse, more comfortable with close quarters than Earth humans. Again, not better or worse, just different, adapted to the specific social environment of space habitation. Communication with Earth would become increasingly strange over these timescales. Even without relativistic effects, the sheer distance creates lag. A message from Mars takes anywhere from 4 to 24 minutes to reach Earth, depending on orbital positions. From the outer solar system, hours or days. From another star system, years or decades or centuries. Real-time conversation becomes impossible. Instead, you have asynchronous communication, messages sent into the void with responses coming long after. This changes the nature of relationships across the distance. You can't maintain friendships or family bonds in the normal way when every exchange takes years. Instead, communication becomes more like writing to posterity. You're not talking to specific individuals, but to future generations, to people who might not even be born when you send the message. And messages coming from Earth would carry news of people long dead, events long past, a culture that's evolved beyond recognition. As the centuries pass, Earth's messages would become less personally relevant and more like history lessons or anthropological reports. Here's what's happening on Earth that you'll hear about in 50 years. And eventually, the cultural drift would become so significant that Earth's messages might be incomprehensible without extensive context and translation. It would be like modern Americans trying to understand messages from medieval Europe, technically the same language, but the cultural context, assumptions, values, and references would be so different that deep comprehension would be difficult. This raises questions about cultural continuity. What aspects of Earth culture would space colonies preserve? Which would they abandon as irrelevant to their new existence? Would they maintain holidays that commemorate Earth seasons in an environment with no seasons? Would they preserve languages that evolved on Earth with different needs and contexts? Would they maintain interest in Earth art, Earth literature, Earth philosophy, when these things are increasingly disconnected from their lived experience? Some colonies might become cultural preservationists, carefully maintaining Earth traditions as a way of preserving their identity and connection to their heritage. Museums, archives, educational programs dedicated to keeping Earth culture alive, even as it becomes less relevant to daily life. Others might embrace cultural innovation, seeing themselves as forging new traditions appropriate to their new existence, letting Earth culture fade into history. And Earth, watching these colonies diverge, would face its own questions. Do we try to maintain cultural unity across the diaspora, or accept that human culture will fragment into multiple distinct traditions? Do we establish some kind of pan-human governance that includes space colonies? Or do they become fully independent entities with their own political systems? What obligations do we have to each other when we're separated by distances that make mutual assistance nearly impossible? The political structures that would develop in space colonies are fascinating to consider. Democracy as we practice it assumes certain conditions: relatively equal access to information, ability to verify claims, some level of individual autonomy and privacy, free movement, and the ability to replace leaders without existential risk to the society. But many of these conditions might not hold in space habitats. In a closed life support system, where individual actions can threaten everyone's survival, complete individual autonomy is dangerous. When information is scarce and controlled, when technical expertise is essential for survival, when the population is small enough that everyone knows everyone else, when leadership transitions could destabilize critical systems, the political dynamics change fundamentally. Some space colonies might develop highly technocratic systems where those with expertise in critical systems have disproportionate power because they're literally keeping everyone alive. Others might develop strict democratic procedures precisely because the stakes are so high nobody can be trusted with too much power. Still, others might evolve into something we'd barely recognize as governance at all. More like distributed collective decision-making systems where politics as we understand it doesn't really exist. And over 10,000 years, political systems would continue evolving in response to changing conditions, new technologies, shifting population sizes, and different challenges. We might see political forms that have no parallel in Earth history, uniquely adapted to the specific constraints and possibilities of space existence. The economic systems would be equally distinctive. On Earth, economics is fundamentally about the production, distribution, and consumption of goods and services under conditions of scarcity. But the nature of scarcity in space is different. Some things that are abundant on Earth, living space, breathable air, water, food, natural resources, are extremely scarce in space and must be carefully managed. Other things that are scarce on Earth, solar energy, vacuum, certain mineral resources, might be abundant in some space environments. A space habitat's economy might be dominated not by trade and commodities, but by management of life-critical resources and maintenance of essential systems. Money as we understand it might be less relevant than resource allocation systems, work credits, or reputation-based systems. Property rights would have to be reimagined when there's no land to own, and all resources are collectively managed by necessity. Some theorists have suggested that space colonies would inevitably trend toward collectivist economic systems because the interdependence is so absolute. But human ingenuity in creating economic systems is remarkable, and we might see innovations we can't currently predict. New forms of property, new mechanisms for exchange, new ways of measuring value and contribution. The relationship with technology deserves even deeper examination. We've discussed how space-born humans would have a different relationship with technology out of necessity, but the implications are profound. For us, technology failure is inconvenient or costly. A broken phone is annoying. A car breakdown is problematic. A power outage is uncomfortable. But for space colonists, technology failure is potentially lethal. Life support systems, radiation shielding, structural integrity, thermal management, food production, all depend on technology working continuously and reliably. This creates a culture of maintenance, of redundancy, of constant vigilance. Systems would be designed with multiple backups. Maintenance wouldn't be something you do when things break. It would be continuous, scheduled, ritualistic. Education would emphasize understanding systems, diagnosing problems, improvising repairs. The most valued individuals might not be the most creative or intelligent in abstract ways, but those who can keep systems running under adverse conditions. Over generations, this could create almost religious attitudes toward technology and maintenance. Rituals around system checks, sacred protocols for repairs, deep cultural taboos against bypassing safety systems or skipping maintenance schedules. Because the consequences of carelessness aren't just personal, they're collective and potentially catastrophic. But here's where it gets philosophically interesting. At what point does the line between human and machine begin to blur? If you're dependent on technology for every breath, every drink of water, every aspect of your environment, are you really separate from that technology? If future generations enhance themselves with cybernetic implants, genetic modifications, or direct neural interfaces to ship systems, where does the human end and the machine begin? We might see the emergence of truly hybrid human-machine systems, where individuals are as much a part of the ship as the ship is their environment. Not in the crude sense of having mechanical parts, but in a deeper integration where human cognition extends into the ship's computer systems, where the boundary between self and environment becomes porous. This could manifest in various ways. Neural interfaces that allow direct perception of ship systems. You don't check a display to see oxygen levels. You feel them directly, like sensing your own blood sugar. Genetic modifications that allow direct biointerfacing with technology. Distributed cognition, where thinking happens partly in biological brains and partly in ship computers. Collective consciousness, where individuals maintain some autonomy, but are also nodes in a larger network mind. These possibilities might sound like science fiction, but over 10,000 years with enormous pressure to optimize human-machine integration for survival, they're not just possible, but likely. Evolution, both natural and directed, would push toward tighter integration because it provides massive survival advantages. And this raises the fundamental question: would beings this integrated with technology, this adapted to space, this far removed from Earth, still be human in any meaningful sense? They'd have human ancestry. They'd carry modified human DNA, but their consciousness, their experience of being, might be so different from ours that the commonality becomes superficial. Imagine trying to explain to such a being what it feels like to walk in a forest, to feel rain on your skin, to smell ocean air, to experience gravity as a constant downward pull. They'd understand it intellectually, the way we understand what it might be like to be a dolphin or an eagle, but they wouldn't feel it, wouldn't have the somatic, embodied understanding that comes from direct experience. And conversely, they could try to explain to us what it feels like to move in 3 dimensions, without up or down, to perceive ship systems as extensions of your body, to experience time dilation on a relativistic journey, to be part of a collective consciousness. We'd grasp it intellectually, but we'd never truly know the experience. This experiential gap might be the most profound form of divergence. Not just looking different, thinking different, valuing different things, but experiencing consciousness itself in fundamentally different ways. At that point, are we even the same kind of being? The question becomes not, what would 10,000 years in space do to humanity? But rather, would humanity, as we know it, even exist after 10,000 years in space? Or would it have transformed into something else? Something descended from us, but no longer us? Perhaps the most honest answer is that humanity wouldn't be a single thing anymore. There would be Earth humans, still adapted to planetary life, still experiencing consciousness in the embodied, gravity-bound, nature-connected way our ancestors did. And there would be various flavors of space-adapted humans: Martians, Jovians, belt dwellers, generation ship crews, free space habitats, each adapted to their specific environment, each experiencing existence in slightly or radically different ways. And all of them would be legitimate inheritors of the human legacy. The forest-walking Earth human isn't more authentically human than the microgravity-adapted station dweller. The meditation on nature isn't more valid than the meditation on system dynamics. The connection to soil isn't more real than the connection to starship. This is the true meaning of becoming a spacefaring species. Not just spreading human bodies across the cosmos, but allowing human consciousness to adapt to and explore fundamentally different modes of existence. Not preserving humanity in amber, frozen in its current Earth-adapted form, but unleashing its potential to transform, adapt, and diverge in response to new environments and challenges. It's simultaneously a loss and a gain. We lose the unity of a single human species with shared experiences and universal commonalities. We gain the diversity of multiple human-descended species, each exploring different possibilities of consciousness and existence. We lose the certainty of what it means to be human. We gain the adventure of discovering what it could mean. Some find this prospect terrifying: the dissolution of humanity as we know it, the loss of our essential nature, the transformation into something alien. Others find it exhilarating: the next chapter in the long story of evolution, the fulfillment of our potential as a species capable of conscious self-direction, the beginning of a truly cosmic humanity. But perhaps terror and exhilaration aren't the right responses. Perhaps what's called for is humility, recognition that we're part of a process much larger than ourselves, that the story of life doesn't end with us, that our descendants might surpass us in ways we can't predict or imagine. And that's okay. That's how it's always been. We're not the same as our ancestors from 10,000 years ago. Our descendants 10,000 years hence won't be the same as us. That's not failure. That's life. The deep irony is that we venture into space partly to preserve humanity against existential risks, to Earth asteroid impacts, supervolcanoes, climate catastrophe, nuclear war. We want to ensure that even if Earth is destroyed, humanity survives. But as we've explored, the very act of surviving in space for long enough would transform us so completely that what survives might not be humanity as we understand it. We save humanity by changing what humanity is. Is that acceptable? It might have to be, because the alternative, staying confined to Earth forever, carries its own risks and limitations. Earth won't last forever. The sun will eventually expand and sterilize the planet. Long before that, various catastrophes could end life on Earth. If we want life specifically, consciousness, intelligence, the ability to ask questions and seek answers to persist in the universe, it has to leave Earth. And leaving Earth means changing. So perhaps the question isn't whether we should accept the transformation, but how we want to guide it. Because unlike previous phases of human evolution, this one would involve conscious choice. We'd be directing our own transformation to some degree, making decisions about genetic engineering, cybernetic enhancement, adaptation strategies. What values should guide those choices? What should we try to preserve? What are we willing to let go? Different colonies would likely answer these questions differently. Some might take a conservative approach, changing only what's absolutely necessary for survival, trying to preserve as much of Earth human nature as possible. Others might be radically transformative, embracing change and seeing how far they can push human potential in new directions. And most would probably fall somewhere in between, making practical adaptations while trying to maintain some continuity with their heritage. This diversity of approaches would itself be valuable. We wouldn't be putting all our eggs in one basket, betting on a single vision of what humanity should become. Instead, we'd be running multiple experiments simultaneously, exploring different paths, seeing what works. Some colonies might flourish with approaches that others find unacceptable. Some might struggle or fail. The successes would teach us what's possible. The failures would teach us what doesn't work. And maybe, eventually, these divergent branches of humanity would reconnect. Not physically, the distances are too vast, but through communication, through exchange of ideas and culture and genetic information. A vast conversation across light years and centuries, different versions of humanity comparing notes on their experiments in adaptation and transformation, learning from each other's successes and failures. This would be the cosmic conversation, the dialogue of consciousness with itself, as it explores different modes of existence across the universe. Each colony, a voice in the conversation. Each adapted population, a perspective on what it means to be, to know, to question, to wonder. And perhaps that's the real answer to what 10,000 years in space would do to humanity. It would transform our singular nature into plural natures. It would change what is humanity, from a question with one answer into a question with many answers. It would evolve us from a species into a genus, from a single thing into a category of related things. It would make us not just inhabitants of Earth, but participants in the cosmos. Not just one way of being conscious, but many ways. Not just humanity, but humanities. Is that still us? In some sense, yes, all these divergent forms would trace back to the same origin, carry variations of the same genetic heritage, inherit the same evolutionary history. In another sense, no each would be distinct enough that calling them all by the same name might obscure more than it reveals. But maybe the question of whether it's still us is the wrong question. Maybe what matters isn't preserving some essential unchanging core of humanity, but ensuring that consciousness continues, that intelligence persists, that the universe continues to contain beings who can observe it, think about it, wonder at it, and ask questions about their own nature and purpose. Viewed from this perspective, the transformation of humanity through space colonization isn't a tragedy or a triumph. It's simply the next chapter in the story of matter, organizing itself into patterns complex enough to become aware of their own existence. It's the universe continuing to explore the space of possible conscious configurations, using human-descended beings as one of the vehicles for that exploration. Our distant descendants in their habitats and ships, adapted to microgravity and radiation, thinking in ways we can barely imagine, experiencing consciousness through modalities foreign to us, they'd still be asking the fundamental questions. Who are we? Where did we come from? Where are we going? What does it all mean? The questions that make existence something more than mere survival, that transform living into wondering, that create meaning in a universe that doesn't come with inherent purpose. And in asking those questions, in whatever form they ask them, through whatever sensory modalities they experience the universe, With whatever cognitive architecture they've developed, they'd still be doing the essentially human thing. Not human in the specific Earth-adapted biological sense, but human in the deeper sense of being conscious beings, grappling with consciousness, questioners, questioning the nature of questions. That might be what persists across the transformation. Not the specific form, not the particular mode of existence, but the fundamental orientation toward wondering, questioning, seeking understanding. The trait that made our ancestors look up at stars and wonder what they were, that made us develop language and culture and science and philosophy, that makes us now contemplate spreading beyond Earth, even knowing it will transform us beyond recognition. 10,000 years in space would change almost everything about us. Our bodies, our minds, our cultures, our values, our modes of consciousness, but it might preserve the one thing that makes all the rest possible: the drive to continue, to adapt, to explore, to ask what comes next, and then find out. And perhaps that's enough. Perhaps that's what it means to be human in the deepest sense. Not any particular configuration of matter or consciousness, but the will to persist, to transform, to reach toward what we might become, rather than clinging to what we've been. The cosmos is vast beyond imagining, filled with environments we've never encountered, challenges we've never faced, possibilities we've never imagined. 10,000 years in space wouldn't just change us, it would reveal us. It would show us what human consciousness can become when freed from the constraints of our birth world, when allowed to adapt and transform in response to radically different realities. We are, right now, in this moment, standing at the threshold of this transformation. The technology to begin spreading beyond Earth exists or is rapidly developing. The question isn't whether we can do it, but whether we will, and how we'll navigate the profound changes that will inevitably follow. Each choice we make about space colonization, how we select colonists, what values we embed in colony charters, what technologies we deploy, what adaptations we permit or encourage, is a choice about what future humanity will become. There's enormous responsibility in that. We're not just planning logistics for survival in hostile environments. We're writing the first chapters of stories that will unfold for millennia, shaping the conditions under which our descendants will evolve. So, what would 10,000 years in space do to humanity? It would splinter us into diversities. It would transform our bodies, reshape our minds, revolutionize our cultures. It would create beings that share our past, but not our present, our ancestry, but not our nature. It would turn the human story from a single narrative into an anthology of parallel tales, each exploring different answers to the question of what consciousness can be. And standing here now, at the very beginning of this transformation, we can barely glimpse what those answers might be. All we know is that they'll be different from what we've known, stranger than we expect, and probably more wondrous and more troubling than we can currently imagine. The cosmos awaits, ready to remake us in 1,000 different images, if we're brave enough, or perhaps foolish enough, to venture out and let it. The real question isn't what space will do to us. The real question is whether we're ready to find out.